more time. Let's do another problem. A disk of radius r lies in the YZ plane with its axis along the x-axis and carries a uniform surface charge density sigma. Find the value of x for which Ex equal to sigma over 4 epsilon naught. Can you visualize that? A disk of radius r lies in the YZ plane. Look at that. This is the x-axis, this is the y-axis, and that is the z-axis. So this vertical plane is the YZ plane. So the disk is now like this, vertical in the YZ plane. Its axis is the x-axis. It carries a uniform surface charge density sigma. Find the value of x for which the electric field equal to sigma over 4 epsilon naught. Now, do you remember the equation we derived? What is the equation for the electric field at a point on the axis of a uniformly charged disk? I want to see how many of you remember at least the pattern. The equation is 2 pi k sigma times 1 minus x over square root of r squared plus x squared. Does it ring any bell? Well, it should. You should be familiar with that equation. All right. Now, here is the disk in the YZ plane, and the radius of that disk is r, and this is the x-axis at right angles to the plane of the disk, and this is the x-axis. The field along the x-axis due to a charged disk is given by, all right, one more time, is Ex, electric field along the x-axis of a disk like this that carries a surface charge density sigma, is 2 pi k sigma times 1 minus x over square root x squared plus r squared. And we are told to find the value of x when this quantity will be equal to this. You see, we are told that Ex equal to sigma over 4 epsilon naught. We need to find the value of x where this quantity will be equal to this. All right. So this is equal to sigma over, what I did is, because we are given sigma over 4 epsilon naught as the field value, in our equation here, I replaced k by 1 over 4 pi epsilon naught, and 2 pi k sigma became sigma over 2 epsilon naught. So electric field at a point on the axis, on the x-axis of this disk is sigma over 2 epsilon naught times 1 minus x over square root x squared plus r squared, and this quantity now equal to sigma over 4 epsilon naught. So what all we need to do is take this equation and solve for x. If I leave it like this, can you do that? It is simple algebra. It is at the level of college algebra. So let's take that equation. First of all, you notice sigma and sigma will cancel. Epsilon naught and epsilon naught will cancel, and 2 here will cancel with the 4, leaving a 2 on the denominator. So what all is left on the right side is 1 over 2. Is that right? I want you to look at this. This is our equation. That is our equation. Now this quantity is equal to sigma over 4 epsilon naught. Now sigma on the left cancels with the sigma on the right. epsilon naught on the right cancels with epsilon naught on the right. 2 on the denominator cancels with 4, leaving a 2 on the denominator. Right? That means we got now 1 minus x over square root x squared plus r squared on the left side, and the right side is 1 over 2. And now what I'm going to do is take this negative quantity to the right side, it will become positive. This 1/2 goes to the left. 1 minus 1/2 is 1/2. And that 1/2 equal to this quantity. That's right. So this quantity will be now equal to 1/2. I hope you understood how I got that. And now you can cross multiply, is that right? 2x equal to square root of x squared plus r squared. Can you suggest a way to solve for x from here? I think it is simple. We square both sides to get rid of the square root. 4x squared equal to x squared plus r squared. And moving the x squared to the left, we get 3x squared equal to r squared. Or x squared equal to r squared over 3, or x equal to plus or minus r over square root 3. That means there is a point on the right side where the field will have this value, also a point on the left side. X equal to r over square root 3 is somewhere here. The electric field will be sigma over 4 epsilon naught. Also x equal to negative r over square root 3. There will be a point where the electric field will be sigma over 4 epsilon naught. That is the meaning of that. Okay, another one.